This is basically the summary I'll be reaching today. I'll mainly touch on the SLO concepts, SLO indicator types, SLO architecture. Then I'm going to do a deep dive into transforms. I'm going to be speaking about burn rate alerting. I'm going to show you the demo, and I'm going to wrap it up with SLOs and incident management, a couple of, let's say, conclusions. Let's briefly talk about or revisit some of the SLO concepts. If you are in DevOps or SRE world or platform engineering, you practically, I'm pretty sure that you're very familiar with most of these concepts. But just in case, for the sake of this talk, let's revisit some of them. So the service level indicators are a measure of the service level provided. So usually is defined as a ratio of good over total events. This can be ranging from 0 to 100. For example, you have availability, throughput, request latency, error rate. The service level objectives are the target value for a service level measured by an SLI. So above the threshold, the service is compliant. For example, 95% of the successful requests are served under 100 milliseconds. Then another concept very useful is called error budget. This is defined as 100% minus the SLO. And the quantity of errors basically is the quantity of errors that is tolerated. And the burn rate is the rate at which we are burning the error budget over a defined period of time. It's very useful at alerting before exhausting the actual error budget. So like I said, many of you are, I'm pretty sure you are very accustomed with the terms like SLA, SLI, SLOs. So they all kind of fit together. We kind of correlate them and make sense, in conjunction. So the SLA is the agreement that you, compare your clients with your clients. And the SLIs represent the real numbers on your system performance, whereas the SLOs are the actual goals that your team must hit to meet the SLAs. So they all go together. Why do we use burn rates? It's not really necessary to use burn rate. Some organizations do use them as a measure of, quickly identifying when the organization is using up its cash reserves. Also, it improves the reliability and quality of service. And yeah, basically, it's just like another layer of alerting there that is very useful. And we'll get into that later on. How do we recognize good SLOs versus bad SLOs? And this is kind of important for you to know going further. Bad SLO is vague, subjective, it lacks quantifiable metrics, it has undefined thresholds and no observation window. A good SLO, however, is specific and measurable, user-centric, it's quantifiable and achievable, and time frame defined. A well-defined SLO, in that sense, focuses on a crucial aspect of service quality, provides clarity, measurability, alignment with user expectations, which are essential elements for effective monitoring and evaluation of service reliability. So right now we have visited or revisited the SLO concepts. Right now we're going to be focusing on the SLO indicator types and what are these. I'm going to be speaking about APM availability, APM latency, custom KQL, custom metric, histogram metric, time slice metrics. So these are a few indicators types you'll be seeing or using on Elasticsearch. Don't worry if it sounds too theoretical. We have a chance later on to examine them in a demo. So the APM availability, let's start with the first one, is designed to work exclusively with APM failed transaction rate. You can filter on service name, environment, transaction type, and transaction name. So as you can see from the slide here, you have basically the common user interface window that shows up, and you can start inputting the transaction types, transaction names, etc. All the information that you need. It supports narrow focus with a query filter, so you can add a query filter if you want to. and also supports partitioning by any field in the APM data. For example, such an SLO can be 99% of transactions are successful. Correlated to this SLI is the APM latency. Also is designed to work exclusively with APM transaction latency. You can filter the same as for the previous SLI on service name, environment, transaction type, and transaction name. It supports focus with a query filter, and you can partition by any field present in the APM data. So for example, you can have an SLO like 99% of transactions occur under 200 milliseconds. The custom KQL indicator type is designed to work exclusively with custom logs. The document count for the good filter is used for the numerator, whereas the document count for the total filter is used for the denominator. It supports partitioning by any keyword present in the index pattern. So you can have different SLOs, like, for example, 99% of log messages are not errors. So you can, custom design it for that specific objective. A custom metric SLI is designed to work with metric fields using a sum aggregation. So you have there in the panel a bit how it looks like, and supports basic math, Boolean logic between multiple fields. Also supports partitioning by any keyword present in the index pattern. So you have, for example, such an SLO, 99% of accepted events have been processed. The histogram metric is designed to work with histogram fields. The histogram fields are useful for storing pre-aggregated high-resolution data with minimal footprint. You can define a range for the values. The counts are used for the good and total events, and it supports partitioning by any keyword present in the index pattern. Such an example would be 99% of events have a latency between 0 milliseconds and 100 milliseconds. And not least, the time slice metric supports multiple aggregation. So here you have a panoply like average, mean, max, sum, cardinality, last value, standard deviation, percentiles, and document count. So because of the nature of aggregations and the relationship, sorry, with the bucket size, this indicator forces the user to use a time slice budgeting method. So it's a bit different than the others. And it would allow us to define a custom equation with multiple aggregations, along with a threshold for defining a good slice. Okay, so how does it look in as architecture? How does it basically this graph will tell you a bit more about the transforms, how they correlate with the SLOs, with the ingest pipeline. It's a bit, let's say, theoretical, but let me break it down for you. So the SLOs rely on the transform service to roll up the source data into rollup indices. So in order to support the group by or the partition by feature that I showed you earlier, we have added a second layer which summarizes the rollup data into an entity-centric index for each SLO. This index will also power the search experience to allow users to search and sort by in any SLO dimension. We'll see everything into practice later. So I've been talking about transforms quite a lot until now. What are really transforms? So transforms are persistent tasks that enable to convert existing Elasticsearch indices into summarized indices, which will provide opportunities for new insights and analytics. For example, you can use transforms to pivot your data into entity-centric indices that summarize the behavior of users or sessions or other entities in your data. Or you can use transforms to find the latest document among all the other documents that have a certain unique key. When can you use transforms? You can use them when you need a complete feature test, a feature index, rather than a top-end set of items. You can use them when you need to sort aggregation results by a pipeline aggregation, or when you want to create summary tables to optimize queries. Right now, we will take a look at a bit, taking it step by step, how we can create such transforms in the user interface. So we are here in the stack management in Elastic. In the data on the left side, under management, you have there a panel called transforms, and you can start creating it. You need to choose a data view. For the use case I'm using at the moment, I will select the serverless data view. And then you can select between the two types of transforms. Like I mentioned, it can be either a pivot transform or the latest. In this case, in this example, I'm using the pivot one. And you can define it or, add different options as you wish here with time ranges and so on. You can add different transform details, like the transform ID, the destination index, and here you add the serverless logs, for example, like I used, and different aggregation, and you can group it by, for example, I don't know, something that interests you, like HTTP response status code. Before actually clicking on create, you have the option there to get the payload. So if you want to use this payload in, I don't know, let's say, for example, creating the same transform definition in GitHub, you can just copy to clipboard and you have the definition for later usage. So you click on create and then you have the transform created for you. So after you create the transforms, you can start either creating a couple of things. So either creating directly the transform rule or alert, or the SLO. So the SLO will need to be created after the transform is created. And right now, let's focus how you can create a transform alert. So basically, you need to create, you go to stack management rules, create a rule. You need to select the type of rule that is called transform health. You select your transform that you just created previously, and you enable it. For instance, if you want to be alerting on the transform when it's not started or when it's unhealthy. And you can pair it with a connector type, PagerDuty, Slack, email, Jira, and so on. And you can also you can also start managing your SLOs, transforms, and so on with APIs. So if you like infrastructure as code or just for debugging anything in transforms or SLOs, you can do that with APIs. And we'll see the use case later in the demo how you can do that as well. So I've been mentioning, I've been talking about burn rate alerting. Let's take a bit of, pause here and to deep dive into it. So burn rate alerting calculates the rate at which SLOs are failing over multiple windows of time. They're less sensitive to short-term fluctuations by focusing on sustained deviations. They can give you an indication of how severely the service is degrading, and it helps prioritize multiple issues at the same time. So how do they work? So multiple burn rate alerts, basically they work over multiple windows of time. You have two of them for each severity, so you'll have the short and the long one. The short window is 1/12 of the long window. When the burn rate for both windows exceeds the threshold, the alert is triggered. You have a bunch of advantages for using burn rate alerts. They can help you, reduce alert fatigue. They can improve user experience. You can get a flexible alerting framework, and they have good precision. Also, a bit of, let's say, downsides at the moment, it can be that in the user interface, you have a lot of options to configure. Nevertheless, this is explained, and the options are there to be left in future upgrades of Elasticsearch. So how do they look? The same like for the previous rule, when you created the transform health alert, you can create the rule for the burn rate alerting. So basically, you select creating the rule, you select the type, and you need to choose the SLO that you can pair it with. So a priori, I already created an SLO here, and picked it from the list of SLOs. And then you have the options there that you can play with them. Right out of the user interface, you get some default options. So you can just leave it as it is and you don't need to worry about that, or you can play with it. One of the important options here is called burn rate threshold. And this basically will tell you when it's exhausting the error budget. The same, you can integrate it with different connectors, just as the previous rule. Right, so after seeing all this theory, let's actually start looking in real life through a demo. So I'm here right in the production in Elasticsearch. I'm going to start explaining you the transforms and take it step by step with SLOs and look at it how they are running. Okay, so the transforms here basically under stack management, you see them as a list. You can select either to view them by the health status in case you have any issues, some incidents happening. You want to view them by unavailable, degraded, and so on. And you can click on unavailable transforms. For example, underneath you have a panel for details, messages, health, etc. So pretty useful from the user interface. Right now, let's create an SLO. So for this use case, I will select the custom KQL SLI. And the index, I'll use a serverless index. I will input my query filter and define the good query. It can be something that, it interests you for your specific use case. And the total query as well. You can partition it by, for example, handling server or project ID if you wish. And then you can select your target if you prefer percentile 99 SLO. You can add it here, the duration of time, for example, 30 days, 7 days, and obviously describe your SLO with a short description. Also, a cool feature here under the description will be that you can use tags and you can add as many tags as you want. So it'll be easier for you to identify later on from a list of SLOs, the SLO that you created. You create the SLO, and right after you create it, you start creating the burn rate alert. Like I said, these options come pre-populated. You can leave it as it is, or you can start playing with them. And you can select the connector type as well that you prefer to alert. Right, we save the rule. And then we go and start searching for the SLO we just created. I can see that is grouped by the project ID. So it will give you an indication of each SLO for each project ID. Nevertheless, the SLO is one because you will have just one definition. And you could look at the historical SLI. So what happened in the past, for example, for 30 days, etc. Let me just pause this for a second before jumping into the other part. So once you're defining your SLOs, the burn rate alerts, if you want to use something, let's say that is more visual than the user interface that you just saw for SLOs, you can go ahead and start creating a dashboard. This is very useful, probably, as you know, for reporting or just, in case you are doing an incident reporting, you want to check, for example, some SLOs in a specific region, in a specific environment like production, staging, and so on. So you can go ahead and create a dashboard for it. So let's watch it. From the beginning, you can actually choose the panel for SLOs. And you can choose the SLOs that you want. Obviously, if you have tons of SLOs using project IDs like I created, you'll pick them by hand, so you can add different panels as you want. You can populate as many panels as you want. And as you can see, you also have the option to select the SLO alert. So that means you can pair your actual SLO with the burn rate alert. So it will give you like a nice cool description dashboard with the SLOs and also underneath with the burn rate alerts all in one visualization. The same is pretty straightforward. This part, you save the dashboard, add tags that interest you, and just click on save. Right. The next part I wanted to show after creating such a dashboard is how to interact with the APIs, because I was mentioning previously. Into the DevTools, you have this possibility to interact with the APIs. If you're familiar with Elasticsearch or not, probably already know it by now. So the list of APIs is quite complex, is quite good. You can actually get the number of SLOs that you have. For example, in this case, I have around 143 in production alone. It will give you plenty of information, like, index, description, ID, the filter, the actual queries that you used. So yeah, plenty of information in case you want to debug it. Then you can, get information on the transforms. So, okay, I want to see how many transforms I have in production. Then you can go with get transforms all. There we go, have over 300 transforms in production. And the same, plenty of information here. They are paired with indexes, when they were created, which IDs you have. You can actually get an ID for a transform and, do some troubleshooting on a specific ID, which I'm showing right now. Right, there you go. I can see exactly how my definition for this transform is without, going into the user interface. And then I could do obviously different other, I can interact in different other ways. I can get the stats for a specific transform. I can upgrade, I can delete transforms, SLOs as well. So yeah, these are just some use cases. Plenty of information in case you are, an API person, and you like to toy with that. I'm gonna leave the demo to show you exactly until the end how this is done. Just a few more seconds. Right, as I just explained, you can either delete, upgrade, you can actually even stop transforms. So in case something goes south and you want to, do something like completely radical, just stop the transforms and basically your SLOs won't work anymore. Okay, now that we've seen a bit in practice how this is done, I will summarize a bit the points here. The purpose of SLOs in conjunction with incident management, right? So once you start using SLOs, you're gonna be at the epicenter of different in communication at the epicenter with other stakeholders. So you're not gonna be the only one that will use those SLOs. You're gonna have developers, you're gonna have DevOps engineers, you're gonna have data scientists, you're gonna have product managers, you're gonna have customer support looking at the same data, interacting with those SLOs because they are important. They give you data that is relevant for so many use cases. And for us as engineers, besides the technical parts, okay, they will give you the information that the goals that you need to reach. At the beginning, I was saying that SLOs are important in incident management and in general, they touch a bit of the entire organization because you need to be in constant communication with different stakeholders to understand, the product or, why you need specific SLOs, to understand a bit more the user expectations behind those SLOs. So before actually going into and start creating it, you need to take a second, spend some time discussing with different teams and understanding, do I really need, I don't know, 10 SLOs to create 10 SLOs right now? Will that be useful, or should I start a bit more modest with a couple of SLOs, also with a more modest percentile, instead of trying for percentile 99, just maybe 95 or 90 will suffice. So it's very nice to start a bit modest and go along the way until you understand a bit more the product and why are you using those SLOs. So I added a couple of thoughts or ideas here of what you can use if you really want to use SLOs, and afterwards as well, and how they can involve incident management. So I was mentioning that first you need to understand the user expectations. You're gonna be using an SLO because obviously you're gonna have an SLA, you're gonna have a service level agreement, and you need to also understand those service level indicators as mentioned. You have a lot to choose from, at least from Elastic side. I'm pretty sure in other companies they do the same. So you need to spend more time and figure out which are the best service level indicators for your use case. Then you want to be able to quantify those service level indicators, and you want to consider the user impact. Like I said, maybe you want to start a bit more modest, and not to have a percentile 99 because you don't want to have too much sensitivity in your SLOs. This will mean that a lot of those burn rate alerts will trigger a lot of time, and when you are in production, you're gonna be, let's say, bombarding your SREs with a lot of alerts when is probably not necessary. Then you need to balance reliability and innovation. That means that you need to understand a bit more that where is your product. You need to constantly be communicating with the other stakeholders, understand, did something happen from the user side? Do I need to change something in the definition of my SLOs, etc. Then you need to use that historical data for informed decisions. So not only create those SLOs, but actually take a bit of time from time to time to revise, review those SLOs, look at the historical data, how did we perform, have meetings with your teams, and just understand a bit more that data. You need to keep iterating and refining the SLOs. This will basically give you plenty of good information whether your application or whether your observability tools are performing well, whether it's something coming from the user, from external, or whether it's something that you are doing that you should keep improving. Then SLOs are very important because they will give you a lot of support for monitoring and alerting. Like we saw, there is a very good support with different types of alerts. These are a proactive measure, in case of any incidents. So we create SLOs, to prevent from bumping into incidents. So there will be like another layer of proactive monitoring, if you like to say that. That will tell you, okay, my SLOs are constantly being violated. That means I have to check something. And this will be prior to actually errors flooding into production and you starting to worry about an incident. Not the least, you need to document and communicate. Like I said, please do take time to document a bit more about those SLOs, share them with other stakeholders, and always collaborate across teams. You're not alone. You're not just, as a platform engineer that you're the sole responsible person to create those SLOs. Take time, collaborate with other teams behind those transforms. Actually, there is a machine learning team that created those transforms, so you do need to understand a bit more about transforms, and obviously you need to understand a bit more about the customer. So let's say platform engineers are right at the middle, let's say, and you need to take a bit more time, share those information, and keep upgrading, keep updating, and collaborating. Okay, so in essence, I hope I made it a bit more clear. I give you a bit more information about transform SLOs, how to use them a bit in Elasticsearch. In essence, you'll have a happy SLO if you have a happy transform. A happy SLO doesn't go without a happy transform. So in case something goes south with your SLOs, please take a look at your transforms. Those are, let's say, the mechanisms behind the SLOs, why they are up. Also, in the slides, you'll be seeing some resources that I created for you. Take your time to just look through it if you're curious. Also, you can, if you don't have any questions right now for me, that's not a problem. You can search me on LinkedIn. You can fire up your questions there, or if you want, just to connect. And also, you can check my GitHub repository. Well, I'll be constantly adding my slides from different talks. So if you have a bit more interest outside of this talk, please go ahead and take your time to browse through this. Thank you very much. And yeah, if you have any questions, please let me know.
Nice. Thank you so much, Diana. And yeah, guys, if you have any questions, please drop them in the Q&A chat. Like while you're typing in the questions, I'll also confirm everything that usually comes up after these webinars. We'll send over the slides and reply to everyone who registered, so you don't need to be worried about that. Also, if you join Platform Engineering Slack, you'll probably also see one of the events that is upcoming around Platform Engineering, Platform Con. Diana, are you also going to be speaking there?
No, I am not.
You're not, but check it out for those who hasn't registered yet. It's free. So you can just register and then receive the invitations. But we're going to have lots of cool platform engineering speakers, including Casey Hightower, if you know him. Cool. Back to the questions. APM and KGL are internal tools, applications?
Yeah, so I think you mentioned you're trying to say APM custom KQL, right? So yeah, these are basically like service level indicators used at Elastic. So obviously the use case is for Elastic. Custom KQL is something developed by Elasticsearch. So it will give you the actual possibility to choose specific custom queries or specific query for something that is not predefined. And the APM latency and availability service level indicators are those type of indicators used for application performance. So if you're using Elastic Stack, pretty much you're going to be having those services or your application, and you're going to be seeing your services there in the APM, let's say, panel. And you can basically search, you can basically create those SLOs according to the APM latency or APM availability. So once you start creating such an SLO, you can actually pair it then with your service or your index. And it'll be very nice because you can actually pair it for your use case for your application. So it's, let's say, something a bit more customized for applications in that sense. Yeah.
Cool. Then the second question, how does it look like in real life when a burn rate alert incident happens?
Right. So basically, burn rate alerts are triggering well before an incident actually happens. Like I said, SLOs, we create those SLOs and burn rate alerts before an incident happens, because we have that margin of time or error budget. So basically, depending on the percentile you added, it will be very sensitive or not. But in theory, it will alert you before actually having an incident in production. So how it's happening. For example, if you create such burn rate alerts, you'll be getting a lot of errors. Let's say something goes bad, you're gonna be flooded with lots of those alerts. First, the way it is designed at Elasticsearch, you're gonna have different severities of those burn rate alerts. So you're gonna start with a low, you're gonna have medium, high, and critical. So if you're going to have an incident, you'll be getting a lot of those alerts really, really fast. So you know when to worry. So you're gonna have, let's say, layers or moments when you're gonna see, okay, I'm being hit with this type of error, is showing low, then I'm gonna be showing medium, then I'm gonna show high and critical. Something really is going on. So basically that's a measure for you to understand and to check, right, before something bad happens, that you need to take care of something. And yes, those alerts will be quite, how can I say, not aggressive, but will be quite, they will be quite, verbal in that sense. You'll be getting quite a lot of them, and for you it's gonna be like, you know, reminder to check and see what's happening, why this is going on.
Cool. And Gergely is asking for a real life story.
Oh, right. Real life stories in what sense? Like when you want to create the SLOs or burn rate alerts, or
It's the second question to those burn rate alerts and
okay.
incidents.
Right. Yeah, I mean, it depends. So it depends whether your team actually went along and created those burn rate alerts and those SLOs. Actually, I haven't yet been hit by an incident in production, you know, that offered me this chance. Like I said, this product is quite new. So it's in the last 6 months or so since I created the SLOs and burn rate alerts. They've been functioning quite well, at least in, you know, in the team I'm in, and also in the infrastructure. And you need to understand a bit more the use cases. But yeah, when things go south, you won't be just in theory and in practice. You won't just be hit only by burn rate alerts. It will be things going, you know, alerting you from all different areas. But yeah, I mean, in just a real life case, they tend to be these burn rate alerts quite aggressive. So you know well beforehand that something happened, and yeah, obviously you need to take accounts. I don't know, create an incident and check before, you know, more bad stuff happens.
Nice. Any other questions, guys? If not, we will call it a wrap. And if you have any other questions after this session, you can follow up with Diana in the platform engineering channel, and yeah, just put your questions over there if you haven't joined yet. Also, it's a good opportunity for you to finally join in and connect with fellow platform practitioners. But with that, thank you so much, Diana, for leading this session. Thank you so much for preparing the presentation. We have the presentation already, so we'll send it over tomorrow to everyone who registered. And with that, hope everyone has great evening and enjoy your evening, Diana, as well.
Thank you so much. Have a great evening all. Bye bye.
Cheers.